Hello guys again, I'm on a roll. Another problem for you. Let's read this problem. It says a plate is subject to two forces, A and B, A and B. Why don't they put 60 here immediately? Determine the magnitude of the resultant force and its direction measured from the positive x-axis. By the way, whenever somebody says measure direction, whenever somebody mentions direction, that always has to be measured counterclockwise from the positive x-axis. If they express it differently, it's okay, but then don't call it direction because this is not the accepted way. So let's see what happens here. So how do you do this? Same old, same old. I mean, I'm gonna try to work this scale a little bit here. So if this is 8, I'm gonna make it 4. If this is 6, I'm gonna make it 3. And then you just draw your lines parallel and perpendicular to whatever you have there, and then whatever you have there. Sorry, not really. So this is not in the exactly the x-axis. It should be somewhere here, a little bit lower than that. Now, what else do we know? We know that. Let's see, 1, 2. Let's say. By the way, this is a gusset plate. By the way, do I need that to solve this problem? No. Are you gonna be engineer sooner than you can imagine? So you better start looking at these in the way they are. This is a gusset plate. Those are bolts. And the gusset plate is used for joining several members together. These are bolts, and this is a member, this is another member, these are bolts as well. And by the way, this member, by the looks of it seems to be an angle. So if you make a section and look at this side, that member should be something like this, and the member goes in that direction, and you're looking at that from this point of view here. So this is this part here, and that's why you see this part is the other leg of the angle. Do you need that? Once again, no you don't, but get used to see what you are seeing as an engineer. So if you have this and you have that and you have that, and you know this angle is 60 and you know this angle is 40 and this has to be 180, you know this part here has to be 80. Agree? If you don't agree, you have to. What are you gonna do? Are you gonna chase me and say I don't agree with that? Now, if you complete the parallelogram, and this is a parallelogram, and this is 80, that has to be 80 as well. Now, if this is just, once again, the quadrilateral right there, parallelogram, this is 80, this is 80, these two angles has to be the same value, because everything is symmetric, and they have to add all of them 360. So 360 minus 80 minus 80 is 200, meaning this angle here has to be 100, and this angle here has to be 100. And I think that with that, I have everything that I need to solve the problem. What do we have here to solve the problem? Let's see. Okay, I know this angle, so let's draw that triangle. This, this, and this, kind of. And this is going to be, there goes my scale, but it doesn't matter. This is 6, this is 8, this is my resultant force, and this is 100. That's what I need. And we can apply here the law of cosine and calculate the resultant force. It's going to be the square root of 8 squared plus 6 squared minus 2 times 8 times 6 times cosine of the angle between them, which is 100. So let's see how much is that thing. 36, 8 squared plus 6 squared minus 2 times 8 times 6 times cosine of 100 There you go. And now we take the square root of that, which is the same thing as elevated to the 0.5, and then we get 10.8. My resultant force, 10.8. If that was the only thing asked in the problem will be completed. But the problem is asking also for the direction. So how do we find the direction? We need another angle. So I can calculate, for example, this angle, that angle, because I know this is the x. So if I calculate this angle here, I can basically know what I'm looking for. So yeah, I think that will make it. So let's calculate this angle alpha here. And I can calculate that using the resultant that I just got and using the law of sines. Remember law of sines? Once again, I'm sorry, I'm OCD. Sine of A over A equals sine of B over B equals sine of C over C. I'm gonna keep repeating it until you know it becomes first nature to you. Now what do we do? Sine of alpha divided by 6 has to be equal to sine of 100 divided by r, but r is 10.8. So I can calculate alpha from here, which would be 6 divided by the value that I just got, multiplied by sine of 100, and that would be 0.54. Inverse sine in this calculator, the sine is calculated as twice. I mean, the inverse sine, the first, inverse, the second. Answer, and the angle will be 33.16. Is that our direction? Nope, that's not our direction. Why? Because the directions, if anything, should be measured counterclockwise from the positive x-axis. Now I know that this distance, this, there you go with the distance again. Stop with the distance. This angle is 30 degrees. Why? Because this angle here between the y and the x-axis, this angle is 60. That means that this angle is 30. Correct? And I know the total angle is 33.16. So that means that this little monkey jumping on the bed has to be 3.16. But once again, I don't know. To me, this is not the direction because this is measured clockwise. To me, direction should be that one. And that one will be 360 minus 3.16. And 360 minus 3.16 will be 356.84. So be very careful with whatever. It's a matter of semantics, but it's important because depending on what your professor is asking you to do, or who your professor, or how picky your professor is, then you're gonna have troubles over there. If you say 316 and you give me the drawing and say this is the way the resultant force is oriented with respect to the x-axis, okay, cool, you got it right. But if just for the sake of correctness, if it says direction, remember direction is always measured counterclockwise from the positive x-axis. This is the x-axis, this is the resultant force. That's why you have to go counterclockwise all the way around. Let's try to do this problem now in a different way.